November 10, 1943. Rutschland, Germany. Hauptmann Hans-Werner Lerche walked across the concrete apron toward a Republic P-47 Thunderbolt that sat like an accusation on German soil. The captured American fighter had arrived 3 days earlier, hastily repainted in Luftwaffe markings before Allied fighters could destroy it. Around Lerche, other pilots and ground crew gathered, making jokes about the grotesque American machine. Flying milk bottle, someone called it. Looks like they built it in a refrigerator factory, another laughed. Lerche said nothing. At 27 years old, he was already one of Germany's most experienced test pilots, having flown over 80 different aircraft types. Unlike the combat pilots making jokes, Lerche's job was to understand enemy aircraft, not dismiss them. He had flown captured British Spitfires and Hurricanes. He had tested Soviet fighters, and he had learned that underestimating Allied engineering was a mistake that cost German lives. As he circled the P-47, conducting his pre-flight inspection, Lerche felt growing unease. The aircraft was huge, certainly. Heavy, absolutely. But the construction quality was immediately apparent. Clean welds, precise panel alignment, no shortcuts. This wasn't crude manufacturing. This was sophisticated mass production executed to standards that German factories, increasingly strained by Allied bombing and material shortages, were struggling to maintain. Within 90 minutes, Lerche would complete a test flight that would fundamentally change his understanding of the war. He would sit at his desk that evening and write a report predicting Germany's inevitable defeat, not through lack of courage or skill, but through industrial philosophy. The report would be filed, read, and dismissed. 2 years later, as Germany surrendered, every prediction would have come true. This is the story of the test flight that revealed Germany had already lost the war. How one captured fighter demonstrated that American engineering philosophy was superior not in performance, but in something more dangerous: sustainability. And how German leadership, confronted with evidence of their strategic mistake, chose ideology over reality and doomed their pilots to fight an unwinnable war. Hans-Werner Lerche's path to Rutschland began in 1916 in Breslau, in what was then Eastern Germany. He had been fascinated by flight since childhood, starting with gliders in the early 1930s when powered flight was still expensive and restricted. When Hitler came to power and Germany began secret rearmament in violation of the Versailles Treaty, opportunities opened for young men with aviation skills. By 1939, Lerche was a Luftwaffe test pilot stationed at Rutschland, the primary aircraft testing facility for the German Air Force. Rutschland was Germany's equivalent to Wright Field in America or Farnborough in Britain. Every new German aircraft design passed through Rutschland. Every captured enemy aircraft was evaluated there. The pilots at Rutschland flew more diverse aircraft than anyone else in the Luftwaffe, and their reports influenced procurement decisions and tactical doctrine. Lerche was unusual among test pilots for his engineering background. He understood not just how to fly aircraft, but why they were designed as they were. His reports were known for technical accuracy and brutal honesty. When German aircraft had flaws, he documented them. When enemy aircraft had advantages, he acknowledged them. This honesty had made him unpopular with some Nazi officials who preferred optimistic assessments, but his expertise was too valuable to dismiss. By November 1943, Lerche had accumulated extraordinary experience. He had flown the Messerschmitt Bf 109 in all its variants, the Focke-Wulf 190, the Hunkull and Junkers bombers, experimental prototypes that never entered production. And he had flown captured aircraft: British Spitfires that had force-landed in France, American P-40s captured in North Africa, Soviet fighters retrieved from the Eastern Front. Each evaluation added to his understanding of Allied capabilities. The pattern he had observed was concerning. Allied aircraft, particularly American designs, showed consistent characteristics that German aircraft lacked. They were easier to maintain. They were more forgiving to fly. They had better reliability. German aircraft often had superior performance on paper, but Allied aircraft had better operational availability. and in sustained warfare, availability mattered more than peak performance. The P-47 Thunderbolt that sat at Rutschland in November 1943 had an interesting capture story. Its pilot, a lieutenant from the 355th Fighter Group, had become lost in bad weather during an escort mission. Desperately low on fuel and believing he was over England, he landed at what he thought was a British airfield. Only after shutting down his engine did he realize he had landed at a Luftwaffe base in occupied France. The aircraft was immediately moved inland before Allied fighters could destroy it. The Luftwaffe moved quickly with captured aircraft. Intelligence value was high, but the window for exploitation was narrow. Allied air superiority meant that any valuable target on the ground attracted attacks. The P-47 was flown to Rutschland within days, repainted in German markings, and assigned to Lerche for evaluation. German pilots' attitudes toward the P-47 were dismissive. Intelligence briefings portrayed American aircraft as crude, mass-produced machines built by a nation better at making consumer goods than military equipment. The P-47 seemed to confirm this prejudice. It was enormous compared to German fighters. The radial engine created a barrel-shaped fuselage that looked ungainly. The whole aircraft seemed to embody brute force over elegant engineering. But Lerche had learned not to trust first impressions. British Spitfires had initially seemed fragile to German pilots, until those fragile fighters proved deadly in combat. Soviet aircraft looked crude and poorly finished, until German pilots discovered they were highly effective in the harsh conditions of the Eastern Front. Appearances could deceive. Performance and design philosophy mattered more. As Lerche began his detailed walk-around inspection, the first surprises emerged. The external construction was excellent. Panels fit precisely. Riveting was clean and professional. Access panels were logically placed and well-designed. This wasn't crude construction. This was high-quality manufacturing executed at scale. German factories in 1943 were struggling to maintain quality control as skilled workers were conscripted and replaced by forced labor. The P-47 showed no such compromises. Lerche opened access panels to examine internal construction. Here again, quality was evident. Wiring harnesses were neatly organized and secured. Hydraulic lines were properly routed and protected. The engine installation was remarkably clean. Everything suggested that whoever designed this aircraft had thought carefully about maintenance accessibility. German fighters often required extensive disassembly for routine maintenance. The P-47 was designed so that common maintenance tasks could be performed quickly with minimal disassembly. This was a philosophical difference. German engineering prioritized performance and accepted that maintenance would be complex. American engineering prioritized operational availability and designed aircraft that could be maintained quickly by mechanics of average skill level. In sustained warfare, the American approach had significant advantages that weren't apparent in performance specifications. Lerche climbed into the cockpit and immediately understood why German pilots complained. The cockpit was enormous. A Bf-109 cockpit was so cramped that tall pilots had to slouch to avoid hitting their heads on the canopy. Moving in combat required contorting one's body. Long missions were physically exhausting simply from the confined space. German design philosophy accepted pilot discomfort as the price of minimizing aircraft size and weight. The P-47 cockpit was spacious enough to move comfortably. The seat was well padded. Visibility through the high bubble canopy was excellent in all directions. Everything was within easy reach without straining. And Lerche, trained to evaluate aircraft objectively, realized this wasn't a luxury. This was operational design. Pilots flying A-Tower escort missions to targets deep in Germany needed comfortable cockpits. Fatigued pilots made mistakes. Comfortable pilots were more effective over long missions. The instrument panel revealed more philosophical differences. American instruments used color coding extensively. Green bands indicated normal operating ranges. Red bands indicated dangerous conditions. A pilot could monitor engine status at a glance without reading specific numbers. The layout was logical and organized by function. Fuel controls were grouped together. Engine controls were grouped together. Flight instruments were centrally located. German instruments required precise understanding of specifications. Pilots needed to know that manifold pressure should be between specific values at specific power settings. This assumed highly trained pilots who thoroughly understood their aircraft. The American approach assumed pilots of varying skill levels, possibly including pilots who barely spoke English. The color coding was universal. Green meant good. Red meant danger. No language skills required. Lerche understood immediately what this meant. Germany's training program in 1939 and 1940 had been excellent, producing pilots with hundreds of hours of flight time before entering combat. By late 1943, that training program had collapsed. Fuel shortages meant new pilots received minimal flight training. They were thrown into combat with barely enough hours to solo, let alone master their aircraft. Germany needed aircraft that undertrained pilots could fly safely. Instead, they were building aircraft that required extensive training to operate effectively. He went through the pre-flight checklist systematically. The manual provided with the aircraft was comprehensive and detailed. It assumed the pilot knew nothing and explained everything step by step. German manuals assumed pilot expertise and provided only essential information. This difference reflected different pilot training philosophies and different expectations about pilot quality. Starting the Pratt & Whitney R2800 double WASP engine brought another revelation. The 18-cylinder radial roared to life with a deep, powerful sound, and it ran smoothly, remarkably smoothly. No vibration, no rough patches, no concerning sounds, just smooth, powerful operation. Lerche had flown enough American aircraft to recognize this pattern. American engines were consistently smooth and reliable. German engines, particularly late in the war, were increasingly problematic. This wasn't because German engineers were incompetent. It was because American manufacturing quality control was better. Building one perfect engine in a laboratory was one thing. Building thousands of consistently reliable engines was something else entirely. American factories had mastered mass production while maintaining quality. German factories were losing that capability as the war strained their resources. Lerche received clearance and taxied toward the runway. The P-47's ground handling was excellent. The landing gear was wide and robust, providing good stability. The tail wheel locked, keeping the aircraft tracking straight. Visibility during taxi was good. Everything felt stable and predictable. In a Bf-109, ground handling was a constant challenge. The narrow landing gear made the aircraft prone to ground loops. Visibility over the nose was poor. Many accidents occurred during taxi and landing, even without enemy action. The difference was design philosophy. German fighters accepted difficult handling characteristics as the price of performance optimization. American fighters were designed to be operated safely by average pilots from rough forward airfields. The robust landing gear could absorb hard landings. The good ground handling reduced accidents. In sustained operations, this meant more aircraft remained operational despite the inevitable rough treatment of combat conditions. Lerche lined up on the runway and advanced the throttle. The acceleration was impressive. The massive engine pushed the heavy fighter forward with authority. The takeoff was smooth and straightforward. Gear retraction was hydraulically powered and functioned perfectly. Everything worked as designed with no quirks or unexpected behaviors. Climbing to altitude, Lerche began testing handling characteristics. The P-47 was not agile in the German sense. It didn't turn tightly like a Bf-109. It didn't have the instantaneous response of an FW-190, but it was stable, predictable, and solid. The controls were well harmonized. Aileron response was good, especially for such a large aircraft. The aircraft felt planted and sure, never doing anything unexpected. This was the pattern emerging clearly now. The P-47 wasn't designed to excel in traditional dogfighting. It was designed to be a stable gun platform that pilots could operate effectively without exceptional skill. German fighters required constant attention and quick reactions. The P-47 could be flown by pilots of average ability and still be effective. In an air force increasingly manned by hastily trained pilots, this was an enormous advantage. At altitude, the P-47's strengths became apparent. Above 20,000 feet, the turbo-supercharger maintained full engine power. German fighters relying on mechanical superchargers lost performance as air density decreased. The P-47 actually performed better at high altitude than at low altitude. This meant American fighters could choose the engagement altitude, forcing German fighters to fight where they were disadvantaged. Lerche tested dive performance and was impressed. The accelerated rapidly in a dive and remained controllable at speeds that would have been dangerous in German fighters. The roll rate was excellent. In combat, these characteristics meant the P-47 could dive on enemy fighters, make a firing pass, and escape before the enemy could respond. German fighters that tried to follow would risk compressibility effects that made their controls ineffective. He flew for 90 minutes, testing various flight regimes and maneuvers. The aircraft never surprised him negatively. Every system functioned as designed. The engine never faltered. The hydraulics never failed. The controls remained responsive. And gradually, Lerche understood what he was evaluating. This wasn't the ultimate fighter in terms of peak performance. This was the ultimate operational fighter designed for sustained warfare. German engineers designed for maximum performance assuming perfect conditions. American engineers designed for sustained operations assuming imperfect conditions. A Bf-109 in perfect condition, flown by an expert pilot with perfect maintenance, might outperform a P-47 in a turning fight. But how often were those conditions met? How often was maintenance perfect? How often were pilots expert? How often were conditions ideal? The P-47 was designed assuming maintenance would be performed by mechanics of varying skill using parts from different production batches. It assumed pilots might be tired, stressed, or inadequately trained. It assumed aircraft would take battle damage and need to continue flying. Every design decision made sense once Lerche understood this philosophy. The robust construction meant battle damage that would destroy a German fighter would be survivable. The forgiving handling meant pilot errors would be recoverable. The reliable engine meant fewer mechanical failures. The intuitive controls meant faster training. All of it served one goal: keeping more aircraft operational more consistently. Lerche returned to Richlin and landed without incident. The landing was straightforward and forgiving. Ground crew gathered around, eager for his assessment. They expected him to confirm that the grotesque American fighter was inferior to German designs. Instead, Lerche said something that surprised them. "It's the best designed operational fighter I've ever flown." The mechanics looked confused. Best designed. It was huge and heavy and ugly. How could it be well designed? Lerche tried to explain. It's not designed for peak performance. It's designed for sustained operations, and there's a profound difference. That evening, Lerche sat at his desk and began writing his technical report. This was always the critical part of his job. Flying the aircraft was one thing. Understanding what it meant strategically was another. He organized his thoughts carefully, knowing his conclusions would be controversial. The performance section documented facts objectively. Maximum speed at various altitudes, rate of climb, turning performance, dive characteristics, all compared to German fighters. The numbers showed the P-47 was fast at altitude but slower at low altitude. It climbed well but not exceptionally. It turned adequately but not brilliantly. On paper, it seemed unimpressive. But the operational section revealed the deeper truth. The P-47 was designed for reliability over peak performance. Every system was robust and forgiving. Maintenance was simplified through thoughtful design. Pilot workload was reduced through intuitive controls. The comfortable cockpit enabled long-duration missions. The forgiving handling reduced accidents. The reliable engine reduced downtime. Then Lerche wrote the strategic assessment that would prove prophetic, though it would be ignored. The P-47 Thunderbolt represents a fundamentally different design philosophy from German fighters. German aircraft are optimized for peak performance and assume expert pilots and perfect maintenance. The P-47 is optimized for operational reliability and assumes average pilots and field maintenance conditions. He continued, "This aircraft is designed to be operated in large numbers by pilots of varying skill levels. The forgiving handling reduces accident rates. The robust construction increases survival rates. The reliable engine increases operational availability. The intuitive controls reduce training time. Most significantly, every design decision prioritizes sustained operations over maximum performance." The conclusion was stark. Assessment: the P-47 is not crude engineering. It is sophisticated operational engineering. Germany builds fighters for individual excellence. America builds fighters for industrial war. If the Americans can field hundreds of these aircraft flown by adequately trained pilots, our numerical advantages will be negated through superior operational availability. His recommendation was direct. German fighter design philosophy must incorporate operational reliability as a primary requirement, not a secondary consideration. We cannot win an attrition war against an enemy that can keep more aircraft operational more consistently. Lerche signed the report and submitted it through channels. He knew it would be controversial. He expected pushback. What he didn't expect was complete dismissal. The report traveled up the command structure, was read by various officers, and was ultimately filed away. The conclusion was deemed overly pessimistic. The P-47 was still considered a crude American design. German fighters were superior. End of discussion. But Lerche's predictions began materializing almost immediately. By early 1944, P-47 Thunderbolts appeared over Germany in massive numbers. They escorted American bomber formations deep into the Reich. German fighters intercepted them and sometimes achieved victories. But the next day there were more P-47s, always more. The supply seemed endless. Luftwaffe pilots reported increasing frustration. They would damage P-47 severely, hits that should have been fatal, only to watch the American fighters fly home. The rugged construction and redundant systems kept aircraft flying despite damage that would have destroyed German fighters. The Americans weren't building better fighters. They were building more survivable fighters, and survivability translated directly to operational availability. Meanwhile, German fighter production was struggling with mounting problems. Allied bombing disrupted factories and supply chains. Material shortages forced compromises in manufacturing. Quality control deteriorated as experienced workers were conscripted and replaced by forced labor, prisoners, and conscripted foreign workers. Aircraft that should have been reliable developed problems. Engines failed prematurely. Systems malfunctioned. The gap in operational availability widened. The mathematics were devastating. America produced over 15,000 P-47s during the war. At peak production, one Thunderbolt rolled off assembly lines every hour. Germany produced approximately 36,000 single-engine fighters total across all types during the entire war, and German production was constantly disrupted. More critically, American aircraft maintained higher operational readiness rates. A unit with 100 P-47s might have 85 or 90 available for operations on any given day. A German unit with 100 fighters might have 60 available, with the rest grounded for maintenance, lack of parts, or fuel shortages. Lerche continued his work at Richlin throughout 1944, flying more captured aircraft and writing more reports. He flew a P-51 Mustang and was impressed by its combination of range and performance. He flew Spitfires and noted their excellent handling. Each evaluation reinforced his conclusion. Allied aircraft prioritized operational reliability, and that priority was winning the war. The captured P-47 that Lerche had flown was eventually transferred to a special Luftwaffe demonstration unit called Circus Reservius. This unit traveled to frontline fighter bases with captured Allied aircraft, showing German pilots what they faced and training them in tactics to counter Allied advantages. The irony was profound. German pilots received extensive briefings on P-47 strengths and weaknesses, but German aircraft weren't being redesigned to match its operational advantages. By late 1944, the Luftwaffe was collapsing, not because German pilots lacked courage or skill, but because the industrial base couldn't sustain operations. Aircraft sat grounded for lack of fuel. New pilots received minimal training because fuel for training flights wasn't available. Experienced pilots died and couldn't be replaced. Everything Lerche had identified as the American advantage, operational sustainability, was absent from the German war effort. The final months of the war were catastrophic for the Luftwaffe. American and British fighters dominated German skies. The few German fighters that could fly faced overwhelming numbers. Experienced pilots who had survived years of combat were killed by novice American pilots flying superior numbers of reliable aircraft. The elite force that had dominated European skies in 1940 was destroyed not by superior enemy pilots, but by superior enemy industrial philosophy. Lerche survived the war through skill and luck. His careful flying meant he never crashed or seriously damaged an aircraft despite flying over 120 different types. Many of them captured enemy aircraft without manuals or familiarization. After Germany's surrender, he was interrogated by Allied technical intelligence officers who were fascinated by his experiences. They found his reports in German files and asked about his assessments. "You concluded that American aircraft were superior not in performance but in operational design," an American officer noted. "That's an unusual assessment." Lerche nodded. "It was the most important assessment. Your pilots weren't necessarily better than ours individually. Your aircraft weren't necessarily faster or more maneuverable, but you could keep more aircraft flying more consistently. You could train more pilots. You could sustain operations that we couldn't sustain." Was this apparent when you flew the P-47? Immediately. Every design decision made sense once I understood the philosophy. You weren't building for dogfighting supremacy. You were building for sustained operations. The comfortable cockpit meant pilots could fly long missions without fatigue. The forgiving handling meant fewer training accidents. The reliable engine meant less maintenance downtime. The robust construction meant battle-damaged aircraft returned home. Did German leadership understand this? Lerche laughed bitterly. My report was filed and dismissed. The assessment was that I had been demoralized by flying enemy aircraft and had lost my objectivity. German engineering was superior. American engineering was crude. That was the official position. Any evidence to the contrary was dismissed as defeatism. The interrogation revealed a broader pattern. Lerche wasn't the only German engineer who had recognized Allied engineering advantages. Many had written similar reports. Many had made recommendations for changing German design philosophy. All had been ignored because their conclusions contradicted Nazi ideology about German superiority. The post-war years gave Lerche time to reflect on what he had witnessed. In the late 1950s, he wrote his memoir, providing detailed technical accounts of flying captured Allied aircraft during the war. His assessment of the P-47 included the observation that the comfortable cockpit was a shock after the cramped Bf-109. But more importantly, he explained how that comfort was strategic advantage, not luxury. What made Lerche's story significant wasn't just that he flew a captured P-47. Many pilots on both sides flew captured aircraft. What made it significant was that he understood what he was seeing. As a trained engineer and experienced test pilot, he could evaluate not just whether an aircraft was good or bad, but why it was designed that way and what that revealed about industrial philosophy. The P-47 that Lerche flew in November 1943 represented more than one captured fighter. It represented two completely different approaches to warfare. Germany approached World War II as if individual excellence and superior technology could win battles. America approached it as industrial war, where sustained operations and overwhelming numbers would win campaigns. German fighters were magnificent machines when everything worked perfectly. The Bf-109 and Fw-190 were genuinely excellent aircraft in terms of peak performance, but when everything worked perfectly became increasingly rare as the war progressed. Manufacturing quality declined. Maintenance became difficult. Parts became scarce. Fuel became unavailable. The theoretical performance advantages became meaningless when aircraft couldn't fly. The P-47, by contrast, kept flying. It absorbed battle damage and returned home. It operated from rough forward airfields. It could be maintained by mechanics of average skill. It could be flown by pilots with minimal training. And most importantly, there were always more of them. The supply never dried up. The production never faltered. The operational availability never declined. Lerche recognized this immediately when he flew the captured Thunderbolt. His report in November 1943 accurately predicted what would happen over the following 18 months. But his report was filed and forgot because the truth was inconvenient. Accepting Lerche's assessment would have meant acknowledging that German engineering philosophy was flawed, that Nazi ideology about German superiority was wrong, that the war was being lost because of German mistakes rather than enemy advantages. So the report was dismissed. Lerche was considered too pessimistic, and German fighters continued being designed for peak performance while American fighters were designed for sustained operations. The result was inevitable. By May 1945, the Luftwaffe had been destroyed not through lack of courage or skill, but through industrial philosophy that prioritized the wrong things. The lesson Lerche learned from one 90-minute test flight was profound. In sustained conflict, reliability beats peak performance, operational availability beats maximum capability, and design philosophy matters more than individual excellence. The P-47 wasn't the best fighter of World War II in terms of pure performance, but it might have been the best designed fighter because it was designed not for air shows or test flights or record-breaking. It was designed for war. And in war, the side that can keep fighting longest usually wins. Germany had better pilots. Germany had sophisticated technology. Germany had tactical excellence. But America had operational sustainability. And operational sustainability, as Lerche discovered and tried to warn, was the only thing that mattered in industrial warfare. When Lerche climbed out of that captured P-47 on November 10, 1943, he knew something that German leadership refused to accept. The war was already lost, not because Germany lacked courage or determination, not because German pilots were inferior, not because German aircraft were bad, but because Germany was fighting industrial war with artisan philosophy, building Ferraris when the enemy was building Ford trucks. The irony was complete. The test pilot who recognized the truth most clearly, who documented it most accurately, who predicted the outcome most precisely, was ignored. His reward was to watch his predictions come true as the Luftwaffe was ground down by an enemy that could simply keep more aircraft flying more consistently. And decades later, historians would read his report and understand that one man had seen the future in a single test flight, had written it down clearly, and had been dismissed because the truth was too uncomfortable to accept. The P-47 Thunderbolt that Lerche flew was eventually destroyed, either in combat demonstration or Allied bombing, but the lesson it taught survived. German engineering excellence couldn't overcome American operational sustainability. Peak performance couldn't beat sustained availability. And in the end, the war was won not by the best fighters, but by the most operational fighters. Lerche knew it the moment he landed. Germany took 2 more years to learn what he understood in 90 minutes.